Hello everyone, welcome to MA 1203 Business Mathematics. In the next 4 weeks, you will learn about difference equation and also differential equation. And let's start with how we model time. I am Rinovia Simanjuntak, and let's begin with the difference between continuous and discrete. So if we learn about economic, the dynamics of economic is a study of how economic variables evolve over time. Yeah, for example, economic growth. Of course, economic growth will evolve over time. Yeah, it can uh, grow positively or negatively. Okay, so in this dynamic model, we have to date all the variables. Yeah. And there are two options of dating the variables. The first one is by discrete intervals of time. So for example, you want to measure the economic growth once every month, or once every year, or once every 3 months, or whatever. Or you can date the variables continuously. Yeah, so you want to measure the variables at every instant of time. So again, for the example of economic growth, here you want to measure the economic growth at every instant of time. So for those two different options of dating variables, yeah, we have also two different notations. Yeah. So for the first one, if you want to use discrete intervals of time, we usually use this variable here. Yeah, so y subscribe t. Yeah, so the variable subscribe t. While if you want to measure by using continuous dating variables, then we use this one. Yeah, y or the variables bracket t. Yeah, so both t here give us the notation of time, but how they measure are different. Yeah, so the first one we measure discretely, the second one continuously. Okay, so for the discrete time, yeah, we have what we call the difference. Yeah, so the difference in a variable y between two periods is just this one. Yeah, the difference. Yeah, we subtract one period to another. So if we subtract y1 to y0, we usually give notation delta y0. And if we subtract y2 with 1, well, y1, then we usually call it delta y1, and so on and so forth. Yeah, and in general, we have delta yt, which is equal to the difference of yt plus 1 with yt. Okay, so you know what the difference is? Now we can define the difference equation. So what is a difference equation? Of course, it is an equation, yeah, and it has to contain a difference of a variable, yeah. So it has to contain those delta that we have learned before. So this is an example. Yt plus 1 equal to 3yt plus 2, yeah. So yeah, there is a difference here, yeah, between yt plus 1 and yt. And then we can have this one also a difference equation, yeah, because it contains a difference between step t minus 1 with t plus 1, and again a difference equation and another different example. Yeah, so we have 4 different examples of difference equations, and we have some notions of difference equations that you need to learn. The first one is what we call order. What is an order? Order is the highest order of difference contained in the equation. Yeah, the highest order of difference. So for instance, here we have a difference between t plus 1 and t. Yeah, so the difference is 1. Yeah, one step difference. In here, we have difference 2, right? Yeah. In the third example, we have again difference 1. And the second example, we have what t plus 2 and t plus 1, so difference 1. But we also have t plus 2 and t, so difference 2. So the highest order will be 2. Yeah. So here we have the first example, the order is 1. The second example, the order is 2. The third example, the order is 1. And the fourth example, the order is 2 again. Okay. We also have a different notion which we call the autonomous and non-autonomous. Yeah. So what does autonomous mean? If the equation does not depend on time explicitly. Yeah. So this is the keyword explicitly. Yeah. So autonomous if the equation does not depend on time explicitly. Right? So if you see this for example, which one depend on time explicitly? You can see only the second example, right? Because it contains the variable t or the variable of time explicitly. The other, we don't have that kind of situation. Okay, so what are the others equations? The other equation, we call them non-autonomous. Okay, all right. Another notion is about linearity. Yeah, so a difference equation is nonlinear if it involves any nonlinear term of yt plus 1, yt plus 2, or any variables of y. Yeah. Otherwise, we call it linear. Yeah. So again, if we see these four examples, which one involves nonlinear term of yt plus 1, and so on? Yeah. You can see only the third one. Yeah. Why? Because we have a square of yt. This is not a linear term of yt. So this one is a nonlinear difference equation. The others are, of course, linear equation. Okay, so another important notion of difference equation is the solution of difference equations. This is what we want to find, yeah, the solution of a difference equation. Okay, so what is that? That is a function that makes the difference equation true. So if you substitute a function into the difference equations, then the equation will be true. So for example, if we have this difference equation yt plus 1 equal to 2yt, then y equal to 2t is a solution. Why is it a solution? Yeah, because if you see yt, if yt is equal to 2t, then of course we have yt plus 1 is equal to 2 to the power of t plus 1, right? Yeah. And then if we substitute to that one, to the equation, yeah, then we will have here 2t plus 1 equal to 2 times 2 to the power of t. Yeah, and of course this is true. Yeah, so in this case we have y equal to 2 to the power of t is a solution of the difference equation. Okay, so now we move to the continuous variable. Yeah, so what is the differential of a variable y? Yeah, so it is also a difference, but we measure in an extremely small period of time. Yeah, so this is what you have learned before. So if we consider a very small period of time, which is h approaching 0, yeah, then this difference, yeah, divided by the length of the period of time, we call them dy dt. Yeah. Okay, so we can use different notation for dy dt. This one you have learned about in the last semester, and we can also use this notion. Yeah, there is a textbook that will use this notation. Yeah, so y dot instead of y prime. Okay, so that's about differential. And what about differential equation? So, of course, it is an equation and it has to contain a differential or a derivative. Okay, another example. Yeah, this one contain a derivative. Yeah, this one also contain a derivative. This one also contain a derivative, and this is a second order derivative. And again, this one contains a differential. Yeah, okay. So as in differential equation, we also have the notion of order. Yeah, so what is this notation? Order is the highest order of derivative contained in the equation. Yeah, so for example, this is the highest order of derivative, which is 1, 1, this is 2, and this is 3. So the order are 1, 1, 2, and 3 for those 4 examples. Okay, and again we have an autonomous equation, yeah, where it does not depend on time explicitly, very similar to what we have in differential equation. Okay, so from these 4 examples, which one depends on time explicitly? Of course, the first one, yeah, you can see here, we have t squared and we have also cos t. What about the others? No, they don't have. They don't depend on the variable of t explicitly. So they are all non-autonomous equation. Okay, so again, we have also linearity of an equation. Again, an equation is nonlinear if it involves any nonlinear term, yeah, of y, y accent, y double accent, y triple accent, and so on. Yeah, so which one has nonlinear terms of y or y accent or y double accent or so on? Okay, you can see here this y is being squared, yeah, so this is a nonlinear one. Yeah, what about the others? No, they all are linear. Yeah, what about the first one? We have t squared, yeah, but t is being squared, not y, so it is still a linear equation. Okay, so number 1 is a differential equation which is autonomous. Is it autonomous? No, it's not. Yeah, number 1 is non-autonomous, but it is linear with order 1. Yeah, and you can try to deduct what are the type of differential equations for the other examples. Okay, and again, yeah, our objective will be to find solution of a differential equation. Yeah, and there is a function that makes a differential equation true. And if we have this equation, yeah, so here remember you use yt, yeah, here, because this is a continuous function. Yeah, is a solution of y accent equal to b. Is it true? Yes, of course it is true. So you can just use y accent. What is y accent of this? This is just b, and this is exactly the same with the differential equation. So it is a solution. Okay, so that's all for this topic. We will continue with the next video. Thank you for your attention.